The American power grid is shivering. Across the nation, transmission lines hum with a frequency that betrays the strain of an unprecedented surge in demand. It is a load not seen since the industrial boom of the post-war era. Deep within the executive boardrooms of two energy titans, a $67 billion merger is taking shape. This is not a standard corporate expansion. It is a desperate, calculated scramble to feed the insatiable appetite of a new era. Artificial intelligence demands power at a scale that defies previous projections. Every new cluster of servers requires the output of an entire small city to remain operational. As the grid reaches its absolute physical limit, the infrastructure begins to groan under the weight of the digital revolution. The massive merger is the only shield against a total system failure. A high-stakes gamble to consolidate resources before the network hits a breaking point. The stakes are clear. If the energy supply cannot keep pace with the compute, the lights will eventually flicker out. The race to secure the future of intelligence is no longer happening inside a browser or a laboratory. It is happening in the copper, the steel, and the heavy turbines that hold the national economy together. The bet is on the table, and the grid is already beginning to buckle. Nowhere is this pressure more concentrated than in Northern Virginia in the stretch of land known as Data Center Alley. Here, the battle for kilowatts has reached a fever pitch. Where trees and empty fields once stood, massive concrete structures now dominate the horizon, housing rows upon rows of servers that never sleep. The ground vibrates with the low-frequency drone of cooling fans and backup generators. Companies fight for proximity to the main power lines, as if they were fighting for water in a desert. Every square foot of available land is being bid upon, not for its location, but for its capacity to tap into the high-voltage grid. Local utility providers are overwhelmed. They receive applications for new connections that exceed the total capacity of existing substations. The race is frantic. Engineers work in shifts to install massive new transformers, yet the demand arrives faster than the hardware can be bolted into place. It is a localized arms race where the prize is not territory, but the ability to keep the lights on for the next generation of computing. As the sun sets over these server farms, the local grid does not rest. It pushes against the limits of its thermal capacity, straining to feed the hungry machines that have transformed this quiet region into the epicenter of the global power struggle. Consider the arithmetic of the modern data center. A single facility, packed with high-density chips, consumes more electricity in a single hour than a suburban town of 30,000 people. When those servers ramp up to process complex models, the load spikes with a sharp, vertical trajectory of a lightning strike. This is not just an increase in usage. It is a fundamental reordering of how energy is distributed. Local substations, designed decades ago to handle the steady, predictable draw of homes and small businesses, are now tasked with powering massive, monolithic blocks of silicon. The transformers heat up, the oil cooling systems cycle at maximum capacity, and the copper lines reach their thermal limit before the sun even hits its zenith. It is a mismatch of historic proportions. Engineers attempt to bridge the gap by installing massive new transmission arrays, but the pace of server deployment outstrips the pace of construction. Every rack added to these facilities is a direct draw on a system already gasping for breath. The infrastructure is being asked to do the work of a future industrial age using the foundations of the past. It is a precarious balance, one where the sheer volume of energy required threatens to snap the very wires that keep the city lights burning. As the sun dips below the horizon, The reality of the grid's exhaustion becomes visible. Twilight brings no relief. Instead, it triggers the most demanding cycle of the day. Thousands of cooling fans shift into high-speed mode to compensate for the cooling night air, and the load on the local grid surges. In the shadow of the server farms, the hum of the substations changes from a steady drone to a strained, irregular whine. At one major junction, a circuit breaker trips, plunging a row of streetlights into darkness for a heartbeat before the automated fail-safes kick in. It is a warning. The copper wiring, buried deep underground, radiates heat into the cooling soil, a silent testament to the extreme current flowing through lines installed 40 years ago. Every switch, every relay, and every transformer is now operating in a zone of constant, high-stress vibration. There is no slack left in the system. When a single fault occurs, the surrounding lines must instantly absorb the redirected load, creating a cascading ripple of instability. The grid is not merely carrying power, it is holding its breath. Every flicker of an overhead light serves as a reminder that the infrastructure is being pushed past its breaking point, struggling to sustain the digital hunger that never sleeps. While the transformers hum in the dark, the real battleground shifts to the sterile halls of federal oversight. The proposed $67 billion merger between the nation's energy titans lands on the desks of regulators like a seismic event. It is designed to be a masterstroke of consolidation, yet it hits an immovable wall of legislative scrutiny. Federal investigators open the file and find cause for immediate alarm. They see a move toward absolute market dominance that could dictate pricing for every household on the eastern seaboard. The approval process, once expected to be a streamlined formality, grinds to a halt. Officials issue a formal request for information, effectively freezing the deal in a web of bureaucratic red tape. Every day the merger sits in review, the planned upgrades to the power grid remain on hold. The massive capital injection promised by the Titans is locked away behind a legal barrier. For the engineers waiting to break ground on new transmission lines, the silence from the Capitol is deafening. The infrastructure timeline begins to fracture. What was supposed to be a rapid transition to a modern energy network is now a stalled project, caught in a high-stakes standoff. The regulators hold the pen, and for now, they refuse to sign. Inside the boardroom, the atmosphere shifts from legal debate to cold, hard arithmetic. Executives slide a terminal projection across the table, showing the exact date when demand will outstrip supply. They do not argue about market share. They argue about the dark. The figures are stark. They map out a timeline where, without the merger, the regional grid collapses into rolling blackouts by the end of the decade. The lead representative for the energy giants taps his pen against the screen, highlighting the specific substations that will fail first. He explains the cascade effect. One node goes down, the load hits the next, and the entire system enters a terminal feedback loop. Regulators lean in, scanning the data for errors, but the math remains consistent. The executives present a stark choice: approve the consolidation to fund the necessary upgrades, or accept the inevitability of a national power failure. The room goes quiet. The threat of a paralyzed economy hangs over the table, replacing the previous talk of corporate dominance. The regulators stop searching for legal loopholes and start looking at the grid maps. The standoff has reached its boiling point. For the first time, the Federal Committee is forced to consider that their regulatory grip might be the very thing pulling the plug on the nation. The solution emerged not from the legislative halls, but from the industrial ghosts of the past. The narrative shifted entirely toward the atom. Executives reached into the archives, pulling out blueprints for nuclear plants that had been slated for permanent decommissioning. These sites, once considered obsolete liabilities, were now identified as the only source of steady, carbon-free baseload power capable of sustaining the hunger of AI clusters. The transition was immediate. Heavy machinery rolled onto the grounds of facilities that had sat silent for decades. Teams of technicians arrived to peel back the layers of dust and rust, assessing the integrity of containment domes and reactor cores. They were not building from scratch, they were resurrecting. Every valve, every coolant pipe, and every turbine was subjected to a rigorous stress test. The goal was to return these dormant giants to full operational capacity within months, not years. This was the pivot. The grid could not rely on the intermittent supply of wind or solar, nor could it survive the carbon limits of coal. The atom became the anchor for the entire infrastructure strategy. As the first reactor was cleared for a restart, the industry recognized that the future of computing was no longer tied to the grid of the past, but to the reclaimed power of the nuclear age. The grand strategy collapsed into the mud of the work sites. Here, the struggle was not measured in billions, but in pounds of copper and tons of steel. Engineers labored in the shadow of 40-year-old transmission towers, stripping away layers of oxidation from lines that had not seen a major overhaul since the late 80s. The work was relentless. A crew worked to replace a massive transformer, its oil-slicked cooling fins caked in decades of grime. As they tightened the final bolts, the metal groaned under the tension of the massive cables. Suddenly, a hairline fracture appeared in the porcelain bushing. A sharp, high-pitched hiss signaled a pressure leak, forcing the team to halt and scramble for replacement parts that were increasingly difficult to source. Every component was a relic from a different industrial age, now tasked with carrying the volatile load of modern computing. The reality was clear. The digital revolution was running up against the physical exhaustion of the existing grid. Hands stained with grease and grit, the technicians fought to bridge the gap between decaying infrastructure and the insatiable demand of the server farms. They were the front line, manually forcing the rusted backbone of the nation to bear a weight it was never engineered to carry. If the copper failed, the code stopped. Inside the climate-controlled silence of a new data center, the switch flipped. 1,000 server racks surged to life, drawing an immediate, massive load from the local substation. Outside, the impact was instantaneous. The air around the substation transformers began to vibrate with a low, guttural hum that grew into a sharp, metallic whine. Oil expanded within the cooling jackets. The copper coils inside the transformer unit groaned under the sudden, violent demand for amperage. A blue arc of electricity jumped between two high-voltage insulators, leaving a scorched mark on the ceramic. The local grid was no longer just operating, it was screaming. Every new row of servers acted like a vacuum, pulling current until the safety breakers rattled in their housings. A technician watched the gauges. The needle hit the red zone and stayed there, trembling. This was the physical manifestation of the boardroom war in Washington. Attorneys argued over market dominance, but here, the reality was simpler and more dangerous. The transformers were running hot enough to soften the insulation on the wiring. If one more bank of servers came online, the entire local loop would trip, plunging the surrounding area into darkness. The grid had reached the absolute edge of its capacity. The physical infrastructure was holding by a thread, mirroring the fragile, high-stakes standoff currently unfolding in federal courtrooms. The legal battle in Washington continues, but the industry has stopped waiting for a verdict. $67 billion remains locked in the balance, a monumental wager on the necessity of consolidation. If the deal fails, the expansion of artificial intelligence hits a permanent, hard wall. If it succeeds, it establishes a new precedent for how energy giants will dictate the terms of the digital age. Investors monitor the proceedings, yet the reality on the ground remains indifferent to the courtroom. The demand for electricity is an absolute physical constant that no regulatory filing can negate. Every megawatt required for the next generation of computing must be pulled from the ground, through transformers and across transmission lines that have reached their absolute limit. The era of pure code is over. The future of intelligence is being forged in the massive power plants and substations that anchor the national economy. Steel, copper, and high-voltage electricity have become the true architects of this transformation. The grid is no longer a hidden utility. It is the final, unyielding frontier. As the sun sets on the server farms, the hum of the transformers remains the only sound that matters. The bet is on the table, and the physical reality of the power grid will decide the winner.